Your answer can only be as precise. It should be precise. That kind of looks strange, but well, spelling, as long as you know what it means, precision, precise. Okay? That's the general rule for all of this. Okay? But we have to get there in a different way with multiplication and division. We got the least precise measurement with addition and subtraction in a different way than we will get with multiplication and division. It's a different setup and a different set of rules. Okay? Multiplication and division is just a more complex form of addition and subtraction. Okay? But because of what we're doing with multiplication and division, we have to use a different set of rules. Okay?
The least precise is the number you get after you solve everything, or?
The least precise measurement would be one of these numbers here. Okay, now, I'm going to put this. I'm going to say except, well, no, that's right here, okay? All right, what I want to be careful about is that there's a difference between measurements or calculated numbers and something called counted numbers. Okay, so what we want to do then is to ignore counted numbers. Okay, I'm glad you asked that question. Huh? Counted? Counted numbers? Well, what are counted numbers? Well, 1, 2, 3, 4, 5. You could say that, okay? Do we have any counted numbers up here in the problem?
Yes.
The ones.
What is it?
2 is a counted number.
Still mark it out or ignore it?
Well, we just kind of ignore it as far as figuring out significant digits, okay? Now, here's the thing. You have to be careful because there are some whole numbers that are measured numbers, okay? But most whole numbers, most of the time, whole numbers are going to be counted numbers, okay? Yes?
Will there ever be a situation where, let's say, 11.3437 grams of TV will equal, like, I'm not saying it will, but will equal 2.5?
Sure.
Okay.
That can happen.
And so then you wouldn't ignore it?
That's correct. Huh? It's not a counted number anymore, that's right.
We only ignore it if it's a whole number.
You only ignore it if it's a counted number. Most of the time, whole numbers are counted numbers, but not always.
What do you mean by ignore?
Huh? I'm going to show you what I mean by that. Okay? All right, so stay with me. Here we go. What I mean by that is, when we're looking for this least precise measurement, we're going to ignore the counted numbers. In fact, when you get into it, we don't need to get into deep. Just so you know, counted numbers are infinitely significant, so that's why we ignore them. Okay? They just don't matter when we're doing the figure out rounding off. Okay? All right. So the numbers that matter then in our problem, when we're trying to figure out significant digits, so 4 significant digits, 4 significant digits, look at the measured or calculated numbers measured or calculated numbers, find the one with the least total digits. And round your answer to that many digits.
Yeah, that's what I was saying.
Huh?
Or
Measured or calculated. Measured or calculated numbers. And round the answer to that many digits. Okay? So it's kind of a three-step thing here. Look at the measured or calculated numbers. That's part one. Part two, find the one with the least total digits. And part three, round your final answer to that many digits. Okay?
So we're not rounding in that?
We are going to round. That's why I'm going back to it now after you guys have a chance to write this down. And we're going to apply this rule to our problem. Huh?
Would you like round it to like, it wouldn't have a decimal place after it, would be like a whole number?
No, the answer, our final answer will have a decimal place. Yep, I'll show you. Everybody got this? All right, go back to our problem. Which one of, so we ignore these two-digit numbers, these single-digit numbers here. Those are counting numbers. We're only going to look at this. This is a measured number. This is either a measured number or a calculated number. Okay? And we figure out which one of those two has the least digits. 12.6. And that has how many digits? 3 total digits. So we want this answer to have 3 total digits. 1, 2, 3. We underline everything after that. And just like when we did addition and subtraction, we use the same rounding off process. In this case, we're going to
1 gram.
1.11 milliliters of lead. Okay, you got milliliters over here. Okay? Yeah, I usually don't have as much time, but if you've got a quick question, I can try to help you before school. Sure. If you're going to try to make up the safety test or something, as long as you come in early enough. I'm here every day at 7:45, or thereabouts. Okay. Well, I'm not really supposed to let you guys come in during lunch because I'm not supposed to keep you from getting your lunch.
Well, if you decide to come up here, obviously you don't.
I'm just saying. I'm just telling you what the rules are. Okay? All right. Any questions?
So let's say we
I'll have third lunch. Okay? If you want to come up here, you can come up here, but I'm not supposed to have you up here doing stuff during your lunch because you're supposed to eat lunch. Okay? I know. Okay. All right. Does that make sense?
Sure.
Yeah.
But you said that like one more time.
Which one? This part right here?
Well, the whole thing that you just read, the counted numbers.
Yeah, okay. So, the big rule here for any kind of significant digit problem, for any rounding problem, this applies to addition, subtraction, it applies to multiplication, division, it applies to exponents and logarithms. Your answer can only be as precise as the least precise measurement of the problem. Okay, that's the big idea that overall this stuff. Okay, but here's the application part of it. All right, this is the part that we can actually use now to figure out how to do significant digits or rounding in multiplication and division. We're going to ignore the counted numbers, and really that's only just a helpful thing. It's not really something you have to even remember. The big thing you have to remember is this one sentence down here at the bottom. Okay, this 3-part sentence. Okay. So for significant digits, you look at the measured or calculated numbers. Okay, and our problem up here, this one's measured, and this is either measured or calculated. Okay, and you can almost always, decimal place numbers are measured or calculated. Okay, so that's a good clue. It's not always true, but it's almost always true. Okay, you look at the measured or calculated numbers, find the one with the least total digits, and round the answer to that many digits. 3 parts. Okay? So go back up here and look. Of the two numbers, we're going to ignore our counted numbers, 1 and 1. Look at our measured numbers and calculated numbers here and here. Choose the one of these two that has the least digits. That would be this one right here. And then we want to round our final answer in such a way that it has the same number of digits as the one with the least digits in the problem. Okay? That seem all right hard? Huh? Shouldn't be. It takes a little while to kind of get it all kind of set in your head, but if you get it now, you're going to have to use this all semester. Every time we do math in here, you got to do this stuff. So get it right now. Yes?
Whatever it's highlighted like 1 over 1.
What now?
Whatever it's I have a question.
Yeah, ask your question. Go ahead.
Whoever is hot, they switch like 1 over 1, and then the 2 measure and 2 measure. So just switch to 1 and 11.3.
Yeah, well, that would be multiplication then. If I have a measure to calculate a number here on the top, then I'd multiply this times that. This is just a combination of multiplication and division. Okay? All right, everybody take a deep breath. Stretch a minute. We're going to do some practice problems. Okay? Yay. Is that what you said? It's a time and date stamp. Just saves me some time. All right. Practice problem. That was a density problem. Okay. Hmm? No, mole. Mole. Mm-hmm. Hmm? Nope. That's right. It's a special unit of measurement. We're going to actually celebrate Mole Day on October 23rd.
I thought it was an animal or something. What?
Huh? That's extra credit. Oh, there is some extra credit involved with it, yes. Just be patient. We'll get there. Let's get your notebooks together, ring binders on Monday, and we'll talk about stuff like that. All right. Shh. Shh. There's several chances to do extra credit stuff in here. All right? Okay. Now, just to help you, the symbol for carbon is a capital C. On the periodic table, there's carbon, there's the capital C. Okay? Eventually, you'll need to know it, yes.
Yes, I did. I was just
Shorthand for grams is G. And although it doesn't help a whole lot, the shorthand for mole is MOL. That's actually how you spell it in German and Latin. Yeah. Okay, so I'll let you guys work in pairs if you'll do so quietly and stay on task. Okay?